What we're looking at is trying to evaluate the new design compaction criteria um, for asphalt mixes. Um, and what we're looking at is how we could put more asphalt in the mixes and verify that we're achieving improved performance in these mixes. And so we collected mixes back in 2006 when I first arrived at Iowa State, and we kept these mixes in storage, so they were available for us to use. Um, and the benefit of that was that they had longer term performance, um, you know, available in the field. So, we can click down, Vanessa. So this was a team effort between ourselves and University of Iowa with David Lee as a sub. Ashley, who now works at Iowa DOT as a state bituminous engineer, had a substantial role with her grad student Kaizen. And then Joe Podolsky was heavily involved, but now Joe works for the Minnesota DOT as an implementation engineer. So it was a great effort on everyone's part here. So basically, what we're looking at is could we improve the mix performance by modifying the gyratory design level by getting more asphalt into our mixes. Next slide. So what we were, page down. Yeah, there we go. So we're looking at different traffic levels between I-235, which is our high volume road, Highway 330, which is kind of that 10 million diesel level, and then a Highway 4, which is a lower volume road. And then we wanted to look at how these mixes were performing in the different performance tests, as well as evaluate the performance in pavement ME. Next slide. So we changed the design criteria in 2016, and then those mixes were not going into effect until 2017, a little bit somewhat, but more in 2018. And so we were looking at also concurrently, the DOT was evolving the asphalt binder grading criteria. Next slide. This kind of summarizes the grading criteria. We have a mistype here in the table. The north and south in the brown areas are flipped. You have, of course, would have a lower temperature grade binder in the north, and then a warmer grade binder in the south. And US 30 is kind of that dividing line between north and south in the state of Iowa. Next slide. So as I mentioned, we're evaluating these different mixes for rutting, cracking, moisture susceptibility, and then determining how this looks in pavement ME. Next slide. As I already mentioned, we're looking at Highway 4 as a low traffic level of less than 1 million easels. Page down, you can see Highway 230 is the medium, and then I-235 was the higher level. And this was kind of the representation of where these mixers were placed. Next slide. So again, we're using compaction criteria of designing a 4% air void. So what happened was we reduced the number of compaction effort. And then if you page down, you can see how overall, with the old design, as an example on Highway 4, the optimum design was 5.5, with the new was 5.7. And so overall, the three different mixes, we did see an increase in the asphalt content. Not quite as much as we had anticipated. We would have thought it had been more like in the order of 0.4% or thereabouts. But nonetheless, we did see an overall increase in the binder content. So for, we go to the next slide and we look at the different performance tests. Is pretty extensive in terms of dynamic modulus, getting master curves, slow number tests for rutting, Hamburg wheel track testing for rutting and moisture damage, disc shape compaction tests for low temperature cracking, and then beam fatigue tests for fatigue cracking as well. And then finally, we were looking at doing some analysis on the results. And then after that, we were doing some pavement ME. So we won't go into all of the details of um, uh, how we attain the optimum binder content and all that. That's fairly standard at this stage. But what we can do on the next slide is highlight the new design levels. And so we were seeing, as an example, on the low volume roads where it's less than 0.3 million easels, the gyration effort was reduced from 76 gyrations to 50. Okay. And so we see this as a more consistent compaction criteria, and we anticipated seeing improved performance. The first test is the dynamic modulus test on the next slide. And it takes a lot of effort to prepare the samples and then conduct the tests. We go to the next slide. To summarize things, we seem to we have better dynamic modulus values on all three mixes. They were statistically essentially the same for I-35 or I-235. And you would think that that would probably be true since we only changed the binder content by about 0.1%. Okay. So we can go to the flow number test. And again, it's for rutting resistance. You can keep flipping through and to the bar chart. And now this is where we're not seeing statistical differences per se, but there's clearly a tendency for the new design criteria to have better performance. So the blue is the new and the orange is the old. And although there's not quite a statistical difference on 235, you can see clearly there's a preference for the new design criteria. So interestingly enough, just a tenth of a percent binder change on 235 did lead to quite a bit of improvement in rutting resistance in terms of flow number. So, you know, if we flip through there and we have all the analysis of variance and stuff in the report, we next go to the Hamburg device. The Hamburg is pretty much a standard test in Iowa. And so we look at rutting and moisture damage in the Hamburg, and we have a bar chart here. Basically, we're seeing whether it's the stripping slope or stripping inflection point. The new design is providing equal or better performance in the new criteria, compaction criteria, than the old. Okay, and so we can go to the next slide and see it. We did find a rather significant difference for both Highway 330 and I-235. The new and design criteria is certainly better, and we're not compromising performance on our low volume roads. The last performance test we ran was the disc-shaped compact tension test for low temperature cracking, and we can see the DCT results on the next slide. Where we're having, whether it's fracture energy or peak load to fracture, we see improvement there. What gets interesting here is we generally want to see our criteria at 480, 490. In the threshold is shown there in red. We're now moving up and getting close to attaining that there with the I-235. Keeping in mind, this was under the old binder specifications. So the new binder specifications, we would anticipate the performance further improving. Next slide. So again, on these test results for the DCT, we see substantially better performance. And we believe that with the newer binder specs put in place, that the performance would be even further improved. All right. The last test, which is more of a research device, is the beam fatigue test. We do use this for interlayers, but other than that, it's mostly a research tool. We can go to the next slide. This is a table of values. Probably the more informative slide is the one showing the graph with the paired results. And generally speaking, we're seeing the fatigue results of the new design is better than the old design. So it's not a big surprise that we would see improved fatigue performance by putting more asphalt in our mixes. That would be somewhat expected. So I
think that
we're
one of his
seeing better
wings are
fatigue performance in our mixes, basically, and it's supported by the statistical analysis. So the last set of criteria we used to evaluate the compaction criteria was the pavement ME, and we wanted to see how pavement ME simulations would anticipate long-term performance. We go to summary of this. The overall transverse cracking prediction in pavement ME was not being met, which would tell us that we need to have better binder criteria. And so we hope that with the improved binder criteria, that criteria would be met. But we didn't have the right mixes because they're much older under the older specification to evaluate that. And but on overall, the ride quality between the old and the new was statistically the same. Okay. And we didn't see any differences for fatigue cracking in the simulations for pavement ME. And we didn't compromise rutting. The rutting was essentially the same and was meeting our performance expectations. So overall, in the project, we demonstrated that the mixes were performing equal or better, and generally had a tendency to be performing better under the new compaction criteria than the old. The one caveat is in terms of the transverse cracking, which would be related to low temperature cracking, we see that that was kind of an area that needed improvement, and we believe, though, although not confirmed, that the field mixes would be meeting or exceeding that criteria now with the newer binder specification put into place.